Hello and welcome to section 4.2. That's chapter 4, section 2, and it starts on page 277. So we're going to do the top part of this page and talk about the vocabulary startup because these are important things for you to know. So we have a graphic organizer of the coordinate plane below. So if we go ahead and take a look at this very top one here, they're pointing to the middle where the x and the y axis meet. And in case you have forgotten, that is called your origin. So we'll go ahead and label that O-R-I-G-I-N. Excuse my bad handwriting. Now we come in here and now each part of the coordinate plane is actually, it has a name, and really we call them by numbers, but this is going to be really important for you to know. And the way they label these is in Roman numerals. So this is coordinate 1, which is represented with I, coordinate 2, coordinate 3, and then coordinate 4, which is IV. So you always start here in the this is positive and positive, and then you kind of go counterclockwise. So 1, 2, 3, 4. That way you remember. Now another point we need to label this one right here. It's pointing to the axis that goes up and down. And hopefully by now we know that this is our y-axis, which means that when we come over here, this one going horizontal is going to be our x-axis. Sorry, write it softly. And it's actually asking us to find a point right here. So this point right here, it means I go over -4, so that's my x value, and my y value is up 3. All right, and that's all I wanted to do for page 277. Now on page 278, we have a key concept here. We're talking about ordered pairs, tables, and graphs, and we're actually looking at some new vocabulary words called domain and range. So if you have an ordered pair and you're trying to find domain and range, however you have to remember this, domain is, it's all of your x's. Yeah, and now your range, these are all of your y's. Now if you have a table, all of these x's here, these are your domains. You can write this in. And then all of your y values over here are going to be your ranges. One way that we can remember this is that domain starts with a D. D comes before R. So domain is X, range is Y. And then if you have a graph like this, you can just find the X and Y values. So the X value for this one is 0. The Y value is going to be -1. So just for this point, the domain is 0 and the range is -1 right there. So right here we have the definition. It says a relation is any relations can be represented as a table and as a graph. The domain of the relations is the set of x coordinates. The range of the relations is the set of y coordinates. So if we look on page here, what page is this? Page 279. Sorry, no, the bottom of page 278 is what it is. It says to express the relations, or the relation 2, 6, -4, 8, -3, 6, and 0, -4 as a table and a graph, then state the domain and range. So we have a couple different objectives here. And we need to first put them in a table. So we have 2 and 6. Remember, it's always x and then y. So that's why the x's are first. -4, 8, -3, 6, and 0, 4. Next is to graph the ordered pairs on a coordinate plane. So if I go to 2, 6, I go over 2, up 6. If I need to go -4, 8, I go over 4, down 8. -3, 6, over 3, up 6. And then 0, -4 is right here. So if I want to do all of the domain, if you look right here, it even has it. Domain is -4, -3, 0, 2. So they pulled all of these x's. Now for domain, make sure that you write it from smallest to biggest. That's why -4 is first. And then for range is the same thing, smallest to biggest. -8, -4, 6. Notice that 6 is on here twice. Okay, you have 2 6's in your y table, the column there, but there's only 1 6 in your range. It doesn't make sense to repeat them. That's why it's like that. All right, now at the top of the next page, page 279, we're going to go ahead and do an example problem. All right, and it says express the relation -5, 2, 3, -1, 6, 2, 1, 7 as a table and a graph, then state the domain and range. So I'm going to go ahead and take these. I know that this first x is -5, and the y that matches with that is 2. And then I have 3, -1, 6, 2, and then 1, 7. Now I need to plot these on the graph, and I do that. I start with -5 and 2, which means I need to go over 5, which is going to not be perfectly on a line, but up 2. So I'm halfway between here. And then 3, -1. Oops, not that one. You got to go down. To the right 3, down 1, right in the middle here. Now the next one is 6, 2, so I go over 6, up 2. This one is on the line here. And then 1, 7, so I go over 1, up 7. That one's in the middle. Okay, so your graph is going to look like this. You should have the 4 points. Now the domain, remember domain is all of my x's, and I go from smallest to biggest. So my smallest one for sure for my domain is going to be -5. After -5, so I've got that one. After -5, the next smallest one is +1. So that one's gone. Now we have +3 and +6. Again, if you have anything repeating, don't put it twice. Now let's look at our range. Right here, the smallest one for range is -1. -1. After that, I have 2 2's. I only need to write it once. So there's a +2 there, and then a +7. So here are my domain and my range. All right, example number 2. It costs $3 per hour to park at the Wildwood Amusement Park. Make a table of ordered pairs in which the x-coordinate represents the hours and the y-coordinate represents the total cost for 3, 4, 5, and 6 hours. So right here the table is made for us. We know x is going to be equal to 3, 4, 5, or 6. And the y output they get, if you're there for 3 hours, well, 3 times 3 gives me 9. 4 times 3 gives me 12. 5 times 3 gives me 15. And 6 times 3 gives me 18. So they've actually already gone ahead and graphed it for you even. So we have the time of 3 hours is $9, 4 is 12, 5 is 15, and then 6 is 18. So we've graphed them. Now if they don't ask us for the domain and range, but we should know that our x's is domain and the y's are range. So let's go ahead and do this last example here. It says a movie rental store charges $3.95 per movie rental. Make a table of ordered pairs in which the x-coordinate represents the number of movies rented and the y-coordinate represents the total cost for 1, 2, 3, 4 movies. So let's go ahead and set up our table here. We know that x represents the total cost, or I guess really it represents the number of movies you see, and then y is going to equal the money. We'll do that. So I need to figure out 1, 2, 3, or 4 movies. If I could write it nicer. Let's try again. 2, 3, 4. And each rental charges a cost $3.95. Let me find my button here. All right, so that means if I want to buy one movie or rent one movie, I'm going to pay the $3.95. That I don't really have to do any math for. I know that already. Okay, I went ahead and brought up the calculator just so we can double check our work. Now, if I rent 2 movies and they each cost me, maybe here. If I rent 2 movies and they each cost me $3.95, I can go ahead and get that total because $3.95 times 2 gives me 7.9. And I can write it as $7.90. Now let's say I want to do 3 movies. I'm going to do 3 times 3.95, which is going to be equal to the $11.85. So I can write that into my graph. And then, of course, the 4th movie here. 4 times 3.95. And that's equal to $15.80. And now we can graph these. So I know that my X's, I already have these labeled right here. These are the number of movies. And then over here I have, let me see if I can write sideways here. I'm just going to put the dollar sign. That way we know. So I have 1 and then 395. So this is not going to be the most accurate graph, I guess, because we do have these ugly decimals, but I can estimate. So I know that 395 is going to be between 2 and 4. For 2 movies, it goes up to 790 between 6 and 8. For 3 movies, I go up to 1185, which is between 10 and 12. That one's a bit off. It really should be closer to the 12 here. And then what for 4 movies is 1580. You can see that kind of makes a nice straight line there.